Hi. Good day to all. Thank you for joining me today. In this video we will explore the basics of numerical computing to perform curve fitting using Python programming language.
Before we start, let me introduce you on our course learning outcome and program outcome for this experiment. At the end of experiment, students will be able to display good practical skills in conducting the experiments using Python during laboratory sessions. Additionally, students will be able to demonstrate verbal and written communication skills in reporting the conducted experiments and project.
There are two main objectives lays in this experiment, which is first is to find an optimal parameters to a function, objective functions, that maps example of inputs and outputs using Python programming language. And secondly, to use curve fitting in SciPy to for a range of different curve to a set of observations. To perform this experiment, you will be needed a computer to write Python programming. To begin, let's get introduced on the most popular question about Python. What is Python? Well, Python is an interpreted, interactive, object-oriented and multi-purpose programming language created by Guido van Rossum in the late 1980s. In its current state, Python is the world's fastest growing and most popular programming language, a language which people and computers both can understand. It is powerful and has an easy-to-use syntax, making it perfect for beginners. Python is getting popular in use not just amongst software engineers, but also amongst mathematicians, data analysts, scientists, accountants, networking engineers. So, you don't have to be a software developer to use Python. People from different disciplines use Python for a variety of different tasks, such as data analysis and visualization, artificial intelligence and machine learning, and for automation purposes. You can also use Python to build web, mobile, and desktop applications as well as software testing. Why Python is so popular? It is because Python is an open source software, which means that is free. You don't have to be a software developer to use Python. Yes, that's mean you could be an accountant, a mathematician, or a scientist, and use Python to make your life easier. And Python is available for all major operating systems. A program written on one system runs without modification on all systems. In this video, we're looking at curve fitting in Python. We will be doing two types of curve fitting for this experiment, which is linear and polynomial. Theoretically, curve fitting is a statistical process for estimating the relationships among variables. Suppose you are measuring some x data and y data that you can make a scatter plot out of. This data likely depends on physical parameters. The x-axis is the independent variable or the input to the function. The y-axis is the dependent variable or the output of the function. In this lab module, Google Colaboratory IDE is used as the platform to write the Python code. Please have your Google account ready and activate Google Colaboratory IDE. Next, the Python code can be written in Google Colaboratory by creating new notebook at the File tab. Now, you can start writing your code. You can simply add code section by click at the plus code or delete the code at the right side toolbar. The first task that we will perform is import heading. For curve fitting we use NumPy-Matplotlib. The main function of course is from the scipy.optimize library that we're looking for a curve fit. Curve fitting involves first defining the functional form of the mapping function, also called the basis function or objective function, then searching for the parameters to the function that result in the minimum error. Now, we're just going to open up and load data set from this website. We will use the so-called Longley's economic regression data set. There are 7 input variables and 16 rows of data, where each row defines a summary of economic details for a year between 1947 to 1962. In this example, we will explore fitting a line between population size and the number of people employed for each year. The example loads the dataset from the URL, selects the input variable as population, x-axis, and the output variable as employed, y-axis, and creates a scatter plot. Running the example loads the dataset, selects the variables, and creates a scatter plot. We can see that there is a relationship between the two variables. Specifically, that as the population increases, the total number of employees increases. First, we will try fitting a straight line to this data. Here, you have a model function f, which is defined as objective. The equation is as simple as y equals mx plus c. Here we use SciPy's curve fit function to get the optimal values of m and c. Next we write the code to plot the curve fitted data. The attribute LOC in legend is used to specify the location of the legend. On top of the scatter plot, we can draw a line for the function with the optimized parameter values. This involves first defining a sequence of input values between the minimum and maximum values observed in the dataset. And finally, the optimal parameters will be specified based on our objective function. For part B in this experiment, let's try a polynomial regression model by adding squared terms to the objective function. By using the same dataset, follow the same procedure for step 1, import heading, and step 2, load dataset, as in part A. Next, I define your own polynomial objective function. Def objective, x, a, b, c. Return a asterisk x plus b asterisk x2 plus c. To find the optimal parameters a, b and c for the polynomial objective function. Y equals x plus bx caret 2 plus c. 3. Generate curve fitting to data x and data y. Next plot the curve fitted data and finally specify the polynomial function. Observe the polynomial line in the context of the observed values from the domain. As for discussion, students are required to discuss the following. 1. Discuss on linear and polynomial curve fitting error for data x and data y. And 2. Discuss on how SciPy is used to fit of different curves to a set of observations. To conclude, in this experiment, you discovered how to perform curve fitting in Python. Curve fitting in SciPy is used to fit a range of different curves to a set of observations. Curve fitting involves finding the optimal parameters to a function that maps examples of inputs to outputs. Unlike supervised learning, curve fitting requires that you define the function that maps examples of inputs to outputs. That's all for this experiment. Thank you for taking the time to watch this video. I hope you found it informative and gained some valuable insights.